Hey chemistry students, welcome to your tutorial on chemical representation, which you may remember as a shorthand form of expressing an atom, ion, or isotope using its atomic number, mass number, chemical symbol, and charge if it is an ion. So that's expressed with this setup up top. So mass number up top, atomic number on the bottom. The X stands for the chemical symbol. Now remember, if it's an ion, there's also going to be a charge up top too as well, but we'll get to that once we get to number 2. Okay, so we're asked to determine the chemical representation for an atom with 31 protons and 39 neutrons. Well, as I've stated before, the number of protons is your identifier. That lets you know which atom on the periodic table you're dealing with. So I'm going to search my periodic table for an element with 31 protons, and I'm going to look for that top number or the atomic number, and I find that I have gallium, which is expressed with Ga. Okay. So I need my mass number. I don't have that quite yet. I do have my atomic number. Remember, that's the same thing as my number of protons. And I have 31. So when I want to find my mass number for an atom, remember you can just look on the periodic table. But I was also given that I had 31 protons and 39 neutrons. So I can just simply add those two together to get my mass number. So 39 plus 31 is 70. And that's it for the first one. Number 2, an ion with 7 protons, 7 neutrons, and 10 electrons. So had it not said ion, this would have been your dead giveaway that you had an ion. There was a difference between your number of protons and the number of electrons. I'm still going to follow the same format. First thing I may want to do is identify the element that I'm dealing with. So I'm going to go search my periodic table for an element with the atomic number of 7. When I do that, I find it's nitrogen. So if I want, I'm going to go ahead and plug in the bottom number, the atomic number or proton number, 7. For my mass number, if I know my number of protons and my number of neutrons, I just add those two together to get my mass number. So 7 plus 7 is 14. Now, I'm not quite done yet. Remember, with ions, you have to express their charge. And we learned before that protons minus electrons will give you your charge, or we learned that we can work backwards to find what we need. So we have 7 protons minus 10 electrons. So 7 minus 10 will give me -3. So my charge is -3. Another way to think about it, as I stated in class, I have 3 more negative electrons. So -3. Each electron extra has a -1 charge. So if I have 3 extra, my charge will be -3. But if you'd like, this equation is short, sweet, and simple as well. All right, number 3. We're still determining the chemical representation. This time we're told it's for an isotope with 35 protons and 53 neutrons. As always, I need to find out what element I am dealing with. So I look on the periodic table for the element that has 35 as its atomic number and proton number. And it's bromine, which is expressed with this Br. So since I know the atomic number, or the number of protons, I'm going to go ahead and fill that in. Now, remember with isotopes, it may have a different number of neutrons than what you may see on the periodic table. So when I'm looking for my mass number, I'm going to add these two together. So 35 plus 53 gives me 88. Okay. So now had that question been determine whether or not this is an isotope, this is when you would go look on the periodic table. Remember, your atomic number is your identifier. That lets you know you're dealing with bromine. If you want to figure out if you have an isotope, check to see how many neutrons you should have based on the element on the periodic table. As always, ask me questions, and thank you for stopping by.